Hey, this is Mr. Krenz, and in this video I'll be reviewing graphing characteristics and graphing transformations. For graphing characteristics, we have domain, range, x-intercepts, and y-intercepts. And I'll slide this up a little so you can see everything. For the domain, I'm looking at the possible x values. We're assuming that there are arrows when it hits the edge of the graph here. And you see this arrow goes infinitely to the left, this arrow goes infinitely to the right. Domain, I'm talking about x's, which are horizontal, so it covers everything possible. Because it's everything, it's going to say all real numbers. Okay. For the range, I'm looking up and down. I'm looking at the possible y values. Now in this case, I see actually that there's a low point. So it's everything from here, which is at -1, and then everything goes above that. So I have to write somehow a statement that says y is everything that's bigger than -1. So y is greater than or equal to -1. There's nothing below. For the x-intercepts, I look at the x-axis and decide where it intercepts, where it hits it. And that's at the point 1, 0, and 3, 0. From a y-intercept, look at the y-axis, intercepts right here, which is the point 0, 3. Right. Other one. Here I have a graph that goes up and down. My domain, again, is going to be all reals because it goes to the left forever, it goes to the right forever, so it covers everything. Now it's important to note that not all graphs will have domains that are all real numbers. It's just a coincidence that both of these two did. My range is everything that is between 5 and 1 here. So it's kind of a limited spot. Neither side's going to go up to infinity or down to -infinity. My smallest is 1, my biggest is 5, my y's are right in the middle. So then I'll put some inequality signs to make that a coherent mathematical statement. X-intercepts, I look at my x-axis, it never actually intercepts, so I can actually just write none. Perfectly acceptable answer for some functions. And the y-intercept is right there. It's where it hits the y-axis, and then is the point 0, 3. Alright, moving on to graphing transformations. Okay. I have the graph f of x here, and I want to sketch the graph of -2 times f of x. Now, from what I know about transformations, the negative is going to reflect it over the x-axis, so I'll take it here and reflect, and then the times 2 is going to stretch it out to make the y values twice as far from the x-axis. Now, you could do these things separately. You could do the reflection and then multiply the y values by 2. You could do it the other way around, or you can just do both, which I'll do. So I'm going to say that's -2. F of x is like the y value, so I'm going to multiply all the y values by -2. So I'll start here. The y value at that point is 3. 3 times -2 is -6. So that point is now down here. Y value is 0.0. 0 times -2 is still 0. So that point will actually stay. If I look right here, y value is down 1, so it's -1. -1 times -2 is +2. Y value is 0. 0 times -2 is still 0. And look here. Y value is up 1, 2, 3. 3 times -2 is -6. So I end up with these 5 points, and I get a parabola that is a little bit skinnier and reflected. Second problem here. We're given the graph of g of x and want to sketch the graph of g of x minus 1 minus 2. Now inside the parentheses, we look at that, it's x minus 1, and that's going to shift the graph to the right by 1. That one is a little counterintuitive. It seems like that probably should go to the left, but it goes to the right. This guy right here is then going to shift it down 2 afterwards. So my strategy for this one is take every point, say this guy, and move him 1 unit to the right, and then 2 units down. Right, 1, 2 down. I like to make these points a little bit bigger so I know which ones. And I'll do this to all the important points. Certainly all the maxes and mins, and maybe even the middle here. So I see like points here and here, here. Let's move those all one to the right and 2 down. So 1 to the right, 2 down. 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 And 1 to the right, 2 down. And so from here you can see that we have basically the same shape wave that's just been translated over.